4 point, and if you look at this one here, is 4.9, correct? This is what? 4.9. It is what? 4.9 milliliter. So this is a C, 4.9 milliliter. So you not open this, keep it as is, measure it, and put a piece of paper in the back to just have more vision on the value itself. So let's go for the second one. Let's take B, the red one. So we took the light blue. Let's take the red one here, and you can see here. What you can see here. This is. Somebody can see it here. What's the value here? Somebody can see. This is what? This is 40, correct? So when I see it like this, so I can't. So here it is. Let's put this one here, and it is. And if you look at the bottom of the meniscus, is 40, 44, correct? 45, correct? 45 milliliter. This is 45 milliliter, correct? And it has to be in the same 90 degrees perpendicular on this meniscus, and this another meniscus here. This is the we have 20, correct? And then it goes up. If you look at this, this is 21, 22, 23, and this is 23.5. 23.5 in between. So in between those subdivisions, I can guess the value half, plus minus half a mil, correct? So in between those. So this is will conclude this volume determination. Now if we go for our switch now to our assignment here, correct? We'll have to make first the procedure here. We have to measure those here. So how much is the first one you think is? Well, how much is the reading the first one? Somebody will tell me? How much? And if you tell me, and I will record the whole thing. So how much is the first one? So, as I said, the data is already there. So let's have this data here. So how much is the first reading? The green, the first one, if you look at the green line here is just tell us what the ruler is, the yellow one, correct? The purple and the green is to tell us the value, where the value is. So how much is the first one? It's obvious, is 7, correct? 7 point what? Oh, sorry. I have switches. Where is it? Here. Okay, so here it is. It's 7.1? 7.2. And the units is said in centimeter, already in centimeter. How about the second one? The second one here, how much is it? 1.9, okay. This is 1.9, and the units, basic unit in centimeters, correct? The meter. So, then how about number 3? 34.1? 3, okay. And the unit centimeter. How about the last one here? 77.1? 8. I'll take it from there, okay. So now you can tell how to read those readings, correct? And our readings in this is still what? Not 100% precise, depending how the person will see in between. So it's not really precise. If I want to read this one precise, I have to have a caliper, vernier caliper, which then I have to pinpoint where the start, where the end, and measure it exact. So, we did this one here. That's what your exercise today. You'll take an object, the wooden object here, and then you'll measure its width and length and height, and determine its what volume in centimeter cube. Now let's look at this different. We have 3 different ones, but we have to fill this one here, and we have to know two things about those graduate cylinder with this blue liquid inside. The first one, we have to know what is the exact value of the blue solution inside this graduate cylinder. The second one, what is the subunit division of each graduate cylinder. So the subunit division of each graduate cylinder, and what is the actual volume of the blue solution is. Okay, so let's see the first one. Okay, so what is the value of this? What is the value of each? They ask what is the value of each subdivision. If you look from 1 to 2, how many the volume is? 0, 1, correct? 0.1, correct? 0.1. So the answer is 0.1 centimeter, correct? Or milliliter. Centimeter cube or milliliter. So everybody is following? Why? Because if you look here, 1 and then 0.5, 0.6, 0.7, 2, 2. You can't see? You see the inside there, in front of you. What's that? You want me to pinpoint where is it? Yeah, so it is, if you look at this one here, if you look at there, the subunits, is each subunit, each line, maybe I have to show you here, each line is 0.1 milliliters, correct? And each one, and then what's the total volume is? What's the actual volume here? How much is it? 2 point what? Okay, 2.3. Well, we'll take it from there, but it does not. If I look at this, where's the meniscus? Is it on 3? No. The 3 in the top, correct? So it's what? 2.21, maybe 9, correct, or 5. It's an error. 2.2, 2.215, correct? So 2.25. Why is this? This milliliter. So ml. Why is this? Look at the meniscus at the bottom. The meniscus. What the meniscus is telling me? The curvature here. The curvature. The 3 is in the top, correct? We're not taking the top. We're taking the bottom, which is close to what? 2.9, correct? Close to this. But because the error is large, we'll take 2.25 milliliters. Given and take, correct? Given and take. Because I can guess in between the subdivision is I have to guess, and the error will be around maybe half a mil, correct? Correct. That's I can't, because it's not the divide. If you buy a good graduate cylinder, it will give you even the subdivision divided into another subdivision. So there will be more accurate, and those type of graduate cylinders are very expensive because very hard to calibrate, and therefore the price is very, very high. Let's go for the second one. What is the subdivision in each of those? How much? 1, correct? Because you see here it's increased by 1, so it is 1 milliliter, correct? Now, or 1 centimeter cube, 1 cc. What is the total volume? Look at the meniscus now. If you tell me that's 3, I'll tell you no. The 3 is what? On the top of the meniscus, correct? So, but it's between, again, it's between 12.25, correct? 12.2, and then I'm guessing the 5 here. The 4 digits, I'm guessing it, because I don't know. Unless I have a very good, accurate graduate cylinder, which is calibrated even between subdivisions, I can read. So, this is milliliter. How about number 3? How much is it? 10, everybody agrees? Everybody agrees 10? Okay. So it is 10 milliliter, correct? So what is the total volume here? I know you will agree this is above 450, correct? It's 450, correct? That's above it, correct? 450. And we said everyone with 450. It is 460. I'll tell you, to me, no. But there is a trick here in Microsoft Word. I can blow it up as much as I can. Now it said, if you look at the bottom, it said magnification is 244. This way I will have more view on it's really in the bottom or the top, correct? So Microsoft Word has a magnification lens in the back here. You see there. So I'm now blowing everything up so I can see where. So does it have 460?
Yes. Yeah.
This one, yeah, yes. But how about our reading in the back there? No, the first one, yeah, the first one's not. It's not. But this is 460. Yes, it looks like it. This is 460. Correct. So right here, 460.
You accidentally wrote the value in between what?
What's that?
Over there, you accidentally wrote the value in between what?
Oh. Sorry about this. Yeah, that's sometimes because it's just. I apologize. So, how about the last one? Again, I might be able to even pull it up again, up, so I can see it much better now. Here it is. So how much is it now? What's the units? The units is what? 0.1, correct. And how much the whole total? 3.9. I will take it from there. 3.9, that's good. So this one here will be 3.9 ml, and this subdivision is 0.1 milliliter or centimeter cube. Correct? So now I have to go back and go back with the slider here, my magnifier. So take it up to 100. So go back and slide it down to my 100%. You can see that's my 100% back again. So 100% view. Now we did the Garado cylinder. We did all this here. And now we did all the measurements. Now we have to do some exercise about the significant figures. So now let's look at this. It said how many significant figures those values in your rack, correct? Here just the rules, and here is the whole thing. The rules of zero, correct. All zeros trapped between whole numbers are what? Significant. Whole numbers are always what? Significant. The third rule is, in order to zero to be significant, it has to have two conditions met at the same time. It has to be whole number present and the decimal. If one of them missing, the number will be not significant. Let's go and look at the first one. Let's look at this. Let's highlight this here. This is whole numbers, correct? And I will highlight this one here with the yellow so you can follow me. I'm highlighting this one yellow and bold it and make it bold. Like this. Make it bold and make it red. So now we have this one here. Maybe I'll put it. Put it like this. So now I have 55.552. How many sig figs? How many? 5. Correct? All whole numbers are significant. This is 5. Okay, this is 5. 5 sig figs, correct? The second one, how many? How many is the second one? 24.00. 2? No. Review. I have to have whole number present and the decimal. Is the whole number present before the zeros? Yes. Is the decimal present? Yes. So both the conditions are met. So therefore the zeros there are what? Significant. So how many significant figures do we have here? 4. So I will just write the 4 here. So 4, correct? How about this? The third one? How many? 3. Why? The zeros before the decimal called decorating zeros. Decoration means they have no significance. If I take them out, they have no effect or impact on the value, correct? They are for decoration. It looks good to keep them there. The numbers look very nice for decoration, correct? And therefore they say decorating zeros. Now the zeros after the decimal, without whole number before them, correct? They are what? Not significant, because they are missing one of the conditions. We have to have whole number and the decimal at the same time to justify the significance of the zero, correct? Or those zeros. So now, what I will say on this, how many significance we have? How many? 3 only, correct? 3. Why 3? because it has only 3 significant figures, because the fact is the 0 after before the decimal has no whole number, correct? Are you following? Now this will change, correct? How about if I put here, say 9? I put 9 here in front of this. What the significant figure will be if I put 9?
7.
Will be what? 6, correct? Why?
6, 1, 2, 3,
Will be 4, 5, and 6. Why? Because now I have the 2 conditions are met. I have the whole number before the 0 and I have the decimal. All the zeros, I have how many? 1, 2, 3, 4, 5, 2 and 2, 4, 5, 6, 7. Yeah, this is will be what? Will be 7, correct? Will be, in this case, 7. That's correct. Who is following? 2 conditions have to be met at the same time. The whole number before the 0 and the decimal is present, so therefore is significant. How about the G? How much? 5, correct? Why is the zeros? The decimal is present and there is whole number before the 0. So, correct? And zeros trapped between whole numbers are always significant. So, how many here we have? 5. How about this here? 2, correct? Exponents are not part of the significant figure consideration. Everyone's following? Exponents are what? Are not part of significant figure. So this 4, we are looking for 2. How about here? How many? Those are zeros trapped between what? Whole number, correct? 9 and 3. They are trapped in between. They have to be significant. As the rule is. If the zeros are trapped between whole numbers, they have to be significant. So how many we have here?
5.
5. Very good, very good. It's very professional. So how about this one here?
3.
How much? 3? No, not 3. Look at this. The zeros, they have before them the 6. All the zeros, they have before them what? The 6. And they have the decimal. Both conditions are met. So therefore, they are what? Significant. Yes.
Removing the zeros will have an effect on the value.
When you move the zeros,
Yeah, if you remove
yeah, they have no effect on the value. No.
So what are they significant?
What's that?
Why are they significant?
So significant in the sense because the rule is because they have a whole number for them. We consider them, yes. But they have nothing. Decoration if they have no whole value for them. That's just a rule. But if you take them out, the same thing like decoration and the 0 after decimal, no value, they will be locating zeros. So this one, how many we say? 4 and there will be 7, correct? How about the other one here? How many? 3, correct? Or they say 3, correct? How about here? How much?
2.
How many? 2. The zeros, they have no whole number. That's decorating before the decimal. After the decimal, there is no whole number before them. They locate the 0, but the value of it is there. So they have no value, so they are not significant. Therefore, this is 2. How about here? 4, correct? So now, I want to add 1 to this. If I will add 1 here, and that will give you the idea, just give you an example. How about if I add 5, 6, 0, 9, 8, 0, 0, 0. How much is this?
8.
How much? 8. Somebody will tell me how much? 5, 8. 8. No. What's missing in the condition? Decimal. So the zeros are not what? Significant. The 0 is missing. Correct? So therefore this one will be what? How much? 5. Correct? Everyone's following? Everyone's following? If, how about this? That's a tricky one. I put the decimal after the 0 here. How many we have?
8.
Now the decimal is there, regardless, correct? Whether before or after. But both conditions are met. So how many now we have? 8, correct? So we have 5 and 3, 8. Now I decided to have the decimal, take the decimal from here and put the decimal, let's see, put the decimal here. Decimal here. How many we have here? How many? 8. Why? Because you have the two conditions are met. We have the decimal is present.
It's 9.
Because in Germany,
No, the 8 was the number he was.
That's just the numbers.
What's that?
it wasn't included in the last one.
No, I put the number now, the decimal after and before.
No, they thought that the 8 at the end was included in the number.
Here it is. Look at this. What I did, the first example I did here, I added the decimal here. So how much is it now? How much? 8, correct? Now I'm taking the decimal here, another example here, and then I say, well, the same value, copy and paste the same value, and put this value somewhere here. And instead the decimal, oops, put the other one, but don't worry about it. So I take the decimal from here, another value here, and put the decimal in front here. So how much is this?
8.
How much?
8.
Why is 8? The correct answer is 8. Why? Because you have what? You have the decimals present and what?
Whole number.
Correct. Correct. As soon as I take the decimal out, the whole story will be what? Take the decimal out. So this is 8. But if as soon as I take the decimal out, now I'm missing one of the conditions. This is 8? No. This is 8? No. Because it's missing the other condition. We have to have the two at the same time. The two conditions have to be met at the same time. So this will be what? 5. Everybody following? Yes.
How come J is 5?
J.
I thought exponents.
Where is A, B, C, D, E? This one here?
Bottom right.
The bottom right? This one here?
Yeah.
This one is not. This one is not. It's not 5.
Page number.
This one is 5. That's the page. That's the page
Oh.
number.
Okay.
The
Cool.
page number.
Cool.
Cool yourself down, as I say every time. You have to cool yourself always down. But too much excitement is not always good. So anyway, so how many J will be?
4.
Will be 4, correct? So, and we did all of them, correct? Yes. Now, let's do here. We'll have the calculator answer, and we'll do one example or 2 examples, and then you can do the rest by yourself. So the 2 examples here, that's addition, correct? We'll do addition and we'll do multiplication. So addition rule is the same thing like subtraction rule. Division and multiplication is the same rules, correct? So what's the rules for addition and subtraction? You do all the calculation through the calculator, correct? Put the whole digits of the value, maybe hundreds of digits from the calculator. When rounding off, you look at the decimal, the digits after the decimal. In what addition and subtraction, we look at the digits after the decimal. The least number of the digits will control what? The rounding off, the least one. So let's look at this. This came here, the first, here it's the basic units meter. We added all those 3. Let me just highlight them here on this one here, correct? So I added all those 3 on here. If you look at this, then the answer